Good day, Algebra 2 people. This is Mr. Hotard. Today's lesson is on solving nonlinear systems of equations using the elimination method. Now you might be thinking, wait, I just learned substitution. I barely got that down. Now how do you learn elimination? Yes you do. But the good news is that it's really not all that different. 90% of your work for these problems is going to look just like the substitution method. The only difference is how you start the problem. Sometimes elimination is the easier way to start it. So before we do these, if you just think back to like basic system of equations like this, and this is the prerequisite review we did a few days ago. Number 2, we used elimination to solve this. What was special about this problem that made elimination easy to use? Everything did what? Everything lined up. And it was pretty easy to just distribute something and cancel a variable. Okay, so that's when I want to use it. So as far as when should I use this elimination method as opposed to the substitution method, I want to use this if everything lines up. And it's easy to cancel y. Now that's going to be important. Now notice I said it's easy to cancel y, not x, because most of these problems have multiple x's. If you just cancel one of the x's out, you're still going to hit a dead end. You're going to want to cancel y if you're using the elimination method. So let me just give you the steps and then we'll work a problem. So all these problems, just like regular elimination, first thing we did, and this didn't always have to be done, but in this case, what did we have to do in this problem to make the y cancel out with 5y? We had to distribute a negative 5. So your first step when you're using elimination, if it's not already done for you, you need to distribute whatever you need to cancel y's. Again, you want to make sure you're canceling the y's, not the x's. All right, and then after you do that, you're going to add the equations and cancel y. All right, and then what we're going to do after that, we're going to solve for x. And then just like substitution, we had basically two methods we could use for solving for x. We could use quadratic formula or factoring. All right, same thing here. Solve for x using either factoring or quadratic formula. Or sometimes you could use that square root method, but most of the time it could be factoring. All right, and then the last thing, once you have x, you solve for x. What do you do to find the y number? You plug it back in. You substitute into one equation. Substitute into one equation to solve for y. All right, so let's do these two examples. So if you look at example 1, now, you could use substitution for that, but I'd have to get y by itself. Right now, everything lines up, and do the y's cancel the way they're written now? Yes, they do. So this one is easier to use elimination. Just add the equations, cancel the y's. So that's going to say x squared minus 3x, y's are gone, equal to 10. All right, so I added my equation, didn't have to distribute anything. I'm going to solve for x now. So if you're going to use, whether you're using factoring or quadratic formula, you need to get it equal to what? 0. So let's subtract this 10, put it at the end. That's going to say x squared minus 3x minus 10 equal to 0. Now I'm ready to factor it. You could use quadratic formula, but factoring's faster. All right, I need numbers that multiply to give me negative 10, add to give me negative 3. So that's going to be, it's going to be 5 and 2, but which one's going to be negative? The 5. X minus 5, x plus 2. Now that doesn't mean the answers are negative 5, positive 2. What's that mean for the answers? The answers are positive 5 and negative 2. These are the x values. Now we're not done. We found x. We still need to find y. How do you find y when you know x? You go back and you plug that into either equation. It's going to be easier to use that small equation right there. So I'm going to use negative 4x plus y equal to 2. And just one at a time, I'm going to plug in these answers I got for x. So I'm going to start with the 5. I'm going to do negative 4 times 5 plus y equal to 2. And I'm going to solve that for y. Negative 4 times 5, that's negative 20 plus y equal to 2. Now I'm going to add the 20. Y going to be 22. So that means that first answer, when I plugged in 5, I got 22. And then second part of my answer, what was my other x number? Negative 2. Let's plug that in for x. Negative 4 times negative 2 plus whatever y is has to equal 2. Negative 4 times negative 2, that's 8, plus y equal 2. So what's that mean for y? It's going to be negative 6. Y equals negative 6. So when I plugged in negative 2, I got negative 6. Negative 2, comma, negative 6 is my other solution. All right, let's look at one more. My paper turned sideways. All right, example 2. This one you could use substitution. We did a problem similar to this where you could just plug this whole expression into our y right here. But this one, it might actually be easier to use elimination since everything cancels out. But the y's don't cancel out yet. What would you need to distribute here? You need to distribute a negative to the whole either equation. I'm going to do the second equation. So let's just distribute a negative. Basically, I'll change all the signs of the second equation. So now when I add them together, these y's cancel out. I have just 0 right there, which is what I want. All right, and then 6x squared minus 2x squared is going to be 4x squared. Negative 3x minus x is going to be minus 4x. And negative 13 minus 11 is going to be negative 24. Now, I want to try to factor this. Remember, before you split it up, what's the first thing you look for when you're factoring? Greatest common factor. I could divide out what out of this whole problem? 4. Let's just do that. Let's divide the whole problem by 4. So I'll have 0 right there equals x squared minus x minus 6. Now that's much easier. Let's find numbers that multiply to give me negative 6, that's a times, and add to give me negative 1. So it could be 3 and 2. Which one's going to be negative? Negative 3, positive 2. Big one got to be negative, so it has to give me a negative. So that's going to be 0 equals x minus 3, x plus 2. And then that means my answer is x equals positive 3, x equals negative 2. Almost done. How do you find the y's? You plug those back in. You go back to either equation, doesn't matter which one. I'm going to use the second equation, and I'm going to use the original one before I distribute the negative. So y equals, I'm going to do 2 times 3 squared plus 3 plus 11. So let's see, 3 squared going to be 9 times 2 is 18 plus 3 plus 11. What is that? That's 21, 31, 32. So my first answer is going to be 3, comma 32. And then my other answer, if I plug in negative 2, so y equals 2 times negative 2 squared plus negative 2 plus 11. So let's see, that's going to be 4 times 2, that's going to be 8 minus 2 plus 11. 6 plus 11 is going to be 17. So my other answer is going to be negative 2, comma 17. All right, so now I want you to pause the video and you try these two problems on bottom. Did you do it? Of course you did. Why would you not? Okay, so this first one, the y's don't cancel. What would you need to distribute? I need to start by distributing a negative. Make that a negative 7x, a plus y, and a negative 9. And then when you combine them together, your work's going to look like that. You're going to get x squared plus 2x equals 8. Want to get it equal to 0, so subtract that 8. Give you x squared plus 2x minus 8 equals 0. Factor that. That's going to be x plus 4x minus 2. So that means your solutions are x equals negative 4 and positive 2. Those are the x's. Need to find the y now. So if you use that second equation, negative 7x plus y equals negative 9, plug the negative 4 and the 2 in. Plug them in separately. All right, work that out. Your final answer is you're going to get negative 37 when you plug in negative 4. So negative 4 comma negative 37. And you're going to get positive 5 when you plug in 2. So 2 comma 5. And then this last one, you may have gotten a little stuck on this one because, first of all, when you add these, the y's already cancel. So I would have 3x squared minus 3x equal negative 2. I need it equal to 0, so add the 2. 3x squared minus 3x plus 2 equals 0. This one, I can't divide 3 out. All right, it's going to be hard to factor. This one I want to use quadratic formula. So x equals negative b, positive 3, plus or minus square root of negative 3 squared minus 4 times 3 times 2, all over 2 times 3. When you work out that quadratic formula now, negative 3 squared, is that negative 9 or positive 9? That's positive 9. Negative 4 times 3 times 2, that's negative 24. All over 2 times 3, which is 6. What's 9 minus 24? That's going to give you negative 15. Now remember, if you're getting a negative under the square root, what's that mean for your answer? Has I in the answer. All right, I means those graphs aren't going to touch. So you automatically know that's going to be no real solution. Those graphs will not touch each other. So you could stop right there. If you get a negative under the square root, it is no solution. All right, I hope that was helpful. This is Mr. Hotard signing out.